We were looking at what do we mean by the IS curve and how do we derive the IS curve. So we talked about how, if we go back, okay, the IS curve shows us all combinations of output and interest rate for which our goods market is in equilibrium, where our goods market equilibrium is given to us as by YZ, Z is C plus I plus G plus NX. Right. So now moving forward, we then talked about how do we derive the IS curve, and we did a graphical analysis where we used our investment function and goods market diagram. Now what you want to do is we want to look at how do we mathematically derive the IS curve. For this, we'll choose functional forms for C, I, T, and G, because when we talked about earlier and we said, okay, this is our IS curve, right? IS curve basically represents goods market equilibrium condition YZ, where Z is C plus I plus G plus NX. Now, to mathematically derive the equation of the IS curve, we'll choose functional forms for C, T, I, and G. Suppose we have a goods market of a closed economy, which is characterized by these equations, where C is just a linear function of disposable income, investment has an autonomous component and negatively depends upon interest rate, G and T are exogenously given, IG is G bar and T is T bar. We want to find the equation of IS curve for this economy, given these particular functional forms for C, T, I, and G. So now, we know IS curve shows us all combinations of output and interest rate such that goods market is in equilibrium, where we know goods market equilibrium condition is Y is equal to Z, where Z is C plus I plus G plus NX. So basically, IS curve represents goods market equilibrium. So to find the equation of the IS curve, we start with the goods market equilibrium condition given to us as Y is C plus I plus G, where C in this model is C naught plus C1 Y minus T, T is T bar, I is I naught minus PR, and G is G bar. And from here now what we do is we just combine some like terms. So we combine terms that don't depend upon y and r as c naught minus c1 t bar plus I naught plus g bar. Then we write the y term plus c1 y and then we write minus pr. Now what we do is we can solve for r in terms of y, as when we plot IS curve, we plot it with r on vertical axis and y on horizontal axis. So writing r as a function of y makes it easier to identify slope and vertical intercept of the IS curve in a graph with r on vertical axis and y on horizontal axis. So this gives us our equation of our IS curve. Now here are the two things that we should note. Number one, we could have written the IS equation as y is a function of r rather than r is a function of y, right? So over here, when you're finding the equation of the IS curve, we wrote r is a function of y. Alternatively, we could have also written y is a function of r, right? Which would give us this. Now, both of these, whether you write the IS equation as r is a function of y or y is a function of r, are obviously the same thing written in a different way. Here you've just made r as the subject, here you made y the subject. It's the exact same thing written in a different way. However, since we plot the IS curve with y on horizontal axis and r on vertical axis, writing the IS equation as r is a function of y, which we did over here, that we wrote r as a function of y, the reason was because this makes it easier to identify slope and vertical intercept of IS curve in a graph where we have r on vertical axis, y on horizontal axis. Although we could have written y as a function of r also, it's the same thing written in a different way. But we over there wrote, we solved for r, we made r the subject because this just makes it easier to identify the slope and vertical intercept in a graph where we have r on vertical axis and y on horizontal axis. Right, the second thing we need to keep in mind is the specific form of the IS curve depends upon the assumptions that we make regarding C, I, and G. Right, like we said over here also, that to find mathematically derive the equation of the IS curve, we will choose functional forms for C, T, I, and G. So depending upon the assumptions we make, that will determine the specific form of the IS curve. The IS equation that we have derived only holds under these particular assumptions, right? So this equation holds under these specific set of assumptions. Depending upon the assumptions you make, we'll get a different form of the IS curve. However, regardless of the assumptions, the IS curve is always derived using the goods market equilibrium condition y is equal to z. Because we know the IS curve shows all combinations of output and interest rate for which goods market is in equilibrium. So regardless of whatever functional forms we take for C, I, and G, and NX, we will always start with the goods market equilibrium condition to derive the IS curve.